Hello. As he said, my name is Gavin Roy, and I'm going to be talking about RabbitMQ, our experiences at myYearbook in scaling RabbitMQ. And if you bear with me, I'm going to try something new in this talk that I haven't done before, which is going to have a little bit of interactivity with you guys. So if you have a mobile phone, smartphone, iPhone, Android, or web browser, I'm going to be trying to do at least a few interactive polls that should help me tailor the talk to the audience a little bit. And so what will happen is when I come to a slide that a poll is going to pop up, it's going to have instructions that are going to tell you how to enter your choice in the poll. And I've tried to include not applicable responses in the poll as well, so feel free to use those. So first, a little bit about myYearbook.com. We are the #1 ComScore teen destination on the internet, one of the top most trafficked sites in the United States. And we've been using RabbitMQ since 2009. We use multiple clusters of Rabbit for many purposes, everything from using our messaging to our users, so as a way for our internal systems to put messages into a system that generate emails and SMS messages that go to our users, for a message bus that ties our user experience within the browser to our back-end messaging system, and also for event processing of all sorts of different types. So what I got out of the keynote yesterday is you guys like disaster porn. This isn't really a disaster porn talk, but it kind of is. Doing high-velocity messaging, there is often the risk of accident and your messages getting scattered everywhere. And so we've run into that a few times, and I'll touch bases on those type of items where appropriate. But first, let me talk a little bit about AMQP, because to understand RabbitMQ it's important for you to understand AMQP, which is the underlying core protocol, and how RabbitMQ was engineered to work. Its primary focus is around AMQP, even though it supports other protocols, including XMPP, SMTP, HTTP, and others. Its goal, AMQP, is to be a platform-neutral, vendor-neutral messaging format. And that's a key thing from our perspective, because we talk to RabbitMQ from PHP, Python, C, Erlang. We have the ability to talk to it from Postgres, all sorts of different places across multiple platforms, operating systems. 0.9.1, which is the current version that's implemented of AMQP within RabbitMQ, was finalized in November of 2008, and it was implemented by a core group, mainly JP Morgan Chase, Red Hat, and RabbitMQ Technologies, or Rabbit Technologies at the time, which is now VMware through their Spring acquisition. Now, as of 2011, Microsoft is in the group that's steering AMQP, as well as Novell, Bank of America, Barclays, about 3 or 4 other major banks that you would know. And 1.0 final is going to be released on October 4th, I believe. So it's coming really soon. And Rabbit will support 1.0. I'm pretty sure Cupid and the others will as well. It's fundamentally a different protocol. So it's the things that we're going to talk about still apply, but underneath the covers, it's a bit different. So RabbitMQ, born in 2006, it was released in 2007, and Rabbit Technologies was acquired by SpringSource in 2010. It's written in Erlang and OTP. And there are features about Erlang and OTP that lend itself to be very useful for developing a message bus. In essence, the node-to-node communication, the failover, the idea of designing for failure and having your application recover is very important when you're talking about a highly reliable message bus system. Rabbit talks both AMQP 0.8 currently and 0.9.1, and it has features like clustering, active queues, so if you lose a node, you don't lose any messages. It has a nice management UI and API at this point in time, and a plugin architecture. So that's a good brief overview. What I'd like to know is about you guys and your experience level with RabbitMQ. So if we take that and we try and see how this poll thing works, and if the internet works. So if you text to 22333 or go to that URL, that should be a good range for you guys, and I'll give you just a second here to do that. This is only one of 3, so let's try and keep it from being awkward here. The question is, nope, that's not that one. There we go. Okay, so limited but not practical seems to be the main consensus here, which is good. And let's go back real quick. I wanted to see that. So 24% use it in production. That's looks like about 10 of you. So for the 10 or 12 of you that use it in production, please bear with me as I go through some of the core RabbitMQ and AMQP concepts. Like I said, to know RabbitMQ is really to know AMQP. So a core concept within RabbitMQ is publishers. You want to make sure that you're publishing messages. You're not enqueuing messages. The person who's putting messages into RabbitMQ is a publisher. And you have consumers, and consumers are taking those messages that have been enqueued into queues within Rabbit. So very basic. And you have queues, and I'm sure everybody here knows queues. Within Rabbit, you have some important terms or concepts with queues that in production can bite you if you're not familiar with exactly what they are. In fact, I was having a conversation last night about RabbitMQ, and the concept of durability and persistence in messages came up, and there was some confusion between the concept of a durable queue and whether or not that meant that it stored messages on disk. And it doesn't. Durability within RabbitMQ just means that when RabbitMQ reboots, when you stop the daemon and you start it back up, whether or not that queue definition is going to exist on startup, or messages, if they were persisted to disk, will still exist when you start that daemon back up. It has the neat feature of being able to start up and have a client connect and say, I'm going to declare my own queue. I care about messages of a certain type, and when I go away, delete that queue and any messages left in it. And so that's the auto-delete flag. And it also has the ability to say, hey, I'm going to be the only person, the only consumer that should listen to this queue. So give me exclusive ownership of it. Don't let anybody else come in and steal messages from me. You can also tell it to, as an extension of AMQP, expire a queue. So you can say, hey, I want this queue to exist and I want it to receive messages, but I only want to do so for 300 seconds. And after 300 seconds, make it go away. And in the same vein, you can also say, hey, I care about messages, but I only care about messages that are up to N duration old. So after a message is 60 seconds old, it doesn't mean anything to me anymore, throw it away. So we talked about messages. Messages within AMQP have properties. And those properties include the content type, the encoding, timestamps, user IDs, application IDs. By and large, those properties are, while they're defined, you can use them or not use them. We've found that it's very useful to use them as we get messages in, instead of trying to pack information about the messages that we're sending within the messages themselves, to actually use those properties to our advantage as native data types within the protocol. There's also, when I was talking about that idea of queues and durability and persistence, in RabbitMQ and AMQP, the persistence of a message, whether it gets written to disk before it gets dequeued, is specified at the message level, not at the queue level. And so you set a flag within the message properties with a value of 1 or 2, 1 being that it's non-persistent and 2 being that it's persistent. So queues are great, messages are great, but the cool thing about RabbitMQ, the cool thing about AMQP, is the fact that it works off of a message routing model. It's not just take this message and stick it into a queue, or take this message and broadcast it to everything that's listening. There are advanced constructs within AMQP to allow you to do all sorts of things, to send your message to all sorts of different consumers and queues and systems outside of your consumers. And to do that, we use routing keys. Routing keys, in addition to the exchange concept, which we're going to go over in a moment, determine what gets done with a message. I was talking about those properties in a message. One of the things that you can specify is a CC field and a carbon copy field and a blind carbon copy field, just like within email. And just like within email, if you blind carbon copy a message, recipients of that blind carbon copy basically get wiped out. So the systems that can statefully inspect the properties won't know who you're blind carbon copying to. In essence, you can think of these as additional fields that you can put routing keys into. It also violates the AMQP protocol, the blind carbon copy aspect. That's a RabbitMQ only feature. And one more way that we can route messages and decide where they go is this AMQP concept of a headers exchange. And in a headers exchange, you can define within those message properties a key value table that have arbitrary keys and values of your decision process in engineering what you're going to do. And then you can declare an exchange that is a headers exchange. And with that, you can define some rules that basically say if these headers match, then route these messages here or there or elsewhere. And so that leads me into exchanges. And exchanges are the primary routing construct of what we're going to do with a message when it gets published into RabbitMQ. And so when I take a message and I publish it, it goes into an exchange of some type or another. And then that exchange applies that routing key in some way to get the message to where it's supposed to go. And there are three primary types of exchanges that get talked about a lot. Fan out. Within the fan out, it's a one-to-end pattern. And in essence, with a fan out, you send a message into the fan out, and anybody that is bound to that fan out will receive messages, any queue or any exchange. There are direct exchanges, and that's a one-to-one delivery pattern. And so in a direct exchange, we're going to publish a message in, and anybody who has a routing key that is bound in that exchange for a queue is going to get the message. And we have topic exchanges. And topic exchanges are probably the most interesting exchange type that are natively included within RabbitMQ because it allows for really interesting advanced routing concepts. Using period-limited strings within your routing key, foo.bar.baz, for example, you can use wildcard expression matching to say, show me everything that's related to foo, or show me every bar that's coming in, or show me every foo.bar.whatever, and that will take those messages and put them in the appropriate queues. And so you could say that the common used example is the concept of a news bus. And so I'd have like news.United States, news.Canada, news.Europe. And you can have consumers that are listening to all of the news, and you can have consumers that are listening to just anything coming in for the United States. Just using these wildcard pattern matching concepts. And we have the headers exchanges, and that basically, the rule there is on the headers exchange, you define it as whether it's an any headers exchange, so if any of the headers match between what my binding is looking for and what my message has, or if all of the headers match, then route them to the appropriate queues. Now, what's cool about Rabbit, and there's this really neat growth curve that's happening. We got involved with Rabbit very early on, and there was a wide open ecosystem. Not a lot there, a lot to build on. There wasn't a management UI, for example. So Disney came out with one called Alice. We came out with one called Coney. Brian in the audience wrote a command line tool for managing Rabbit queues. there was a lot going on. And since the VMware acquisition has happened, there's been a lot of maturity in the space of tools managing Rabbit, but at the same time, there's been an acceleration of third-party people coming in and doing really cool things within the plugin architecture, especially when it relates to exchanges. And some examples of that are a newly released content hashing exchange. And so basically, where I talked about that idea of a direct exchange and anybody bound to a routing key within that exchange is going to get a copy of that message. The consistent hash exchange is, in essence, a round robining of queues within that exchange for that same routing key. The RPC exchange plugin is pretty interesting. You basically have this plugin where you can send a message in to Rabbit, and it will take that message and route it to some sort of RPC service that will say, hey, yes or no, you can deliver this message, you can't deliver this message, or let me transform the message on the fly before you go back out into something else. You have a REAC exchange, which will actually take messages and shove them right into REAC, and also take content right out of REAC and put it right into the system. A last value cache that keeps track of the last value coming through the exchange, and so you can always query for whatever the last value is. This was used for a chat room example. There's a lot, there's a wealth, and I really didn't go too deep in this list, but there are easily 5 other exchanges at this point, all at this kind of level of either internally developed within VMware/Rabbit or community members developing just all these different novel exchange types to plug in for these routing mechanisms. There's one more thing about exchanges which are interesting. So I talked about this idea of using a binding key or a routing key and binding it to a queue, and so the messages get from the exchange into the queue somehow. You can also do exchange-to-exchange bindings, which creates a really powerful paradigm for how you think about how you create your architecture for your message bus. And the first thing that comes to mind in talking about scaling came from a talk that I attended a couple weeks ago where the speaker made a very good point. And he was talking at that point about languages. And people will often say, well, Ruby doesn't scale, or PHP doesn't scale, or XYZ doesn't scale. And his point was, languages don't scale. Architectures are what scales. And the same is true within a message bus architecture. The same is true within RabbitMQ. RabbitMQ has gotten some bad publicity for not being scalable. At PyCon this year, there was a talk, and forgive me, I don't remember who was giving it, but it was a large organization, and they were basically saying, hey, we went down the RabbitMQ route, and it didn't scale. Zed Shah was giving a talk on ZeroMQ, and he said, RabbitMQ doesn't scale. RabbitMQ scales fine. It's the architecture that you choose to put together in using the tool that determines whether it scales or not. And so one of the neat things about exchange-to-exchange bindings is they allow you to leverage the fire hose of data that you're putting through Rabbit and move it across the message bus in different ways and architecture out ways to get the data that you care about and add a whole level of flexibility in scaling and data use that you may not have thought of prior to your initial use case. And one of the ways that you address that is this concept of clusters within RabbitMQ. And RabbitMQ clusters are sometimes maligned. I was having a conversation about Rabbit last night, and the person I was speaking with says, oh yeah, we've got a Rabbit cluster, and we're thinking about breaking it up and just using individual nodes because we're having some performance issues with it. It's doing some weird things with RAM, and we don't really know what's going on. Rabbit, being a fairly young product, has been going through some evolutionary steps in how they deal with clustering. So clustering within Rabbit natively uses Erlang VM-to-VM communication processes. And so you have the ability to basically connect into a Rabbit cluster as a Erlang remote shell. And within that Erlang cluster, there's this concept of stats nodes, disk nodes, and RAM nodes. And the stats node basically is responsible for, in a cluster, knowing what's going on in the cluster. What's everybody else in the cluster doing? What queues are where? What are the queue depths in those queues? So he has a job unto his own. And the advice that I gave the person I was speaking to last night was take that stats node and stick it out on its own. That's what we do at myYearbook, is we found that that has enough work to do on its own. And it uses enough memory trying to keep track of what everybody else is doing in the cluster, what all the queues are, all the definitions of the exchanges, all the users, that just taking that stats node and treating it as a master node that you use with the management UI on its own is more than enough work for a single node to do. And then break out and you have disk and RAM nodes. And disk nodes are important if you want to persist your messages and make sure that there is a guarantee that you're not going to lose those messages in case of a node failure. You need to have disk nodes that those are going to get stored to. So when you set that flag in message properties and you set it to 2, you need to make sure you have a disk node that you write to. And by default, when you set up a cluster, the stats node and the disk node are the same node. And that becomes your first primary node. And then when you join something else into the cluster, it becomes a RAM node. The RAM node basically keeps all of its messages in RAM. And this is an important point in scaling. You want to basically make sure that you're putting your queues, when you're defining them through your Rabbit cluster, on the appropriate types of nodes for the messages that you're going to be sending. It's really important to know that if you have a disk node, you're going to be I/O bound. So make sure that you have the appropriate type of hardware to support the message velocities that you need to persist every message that's coming through. And that goes to that point of where does the queue live, right? When you define a queue within a cluster, you can specify the node that that queue belongs to. And so you can say QX lives on node 2, and node 2 is a disk node, and I happen to have a HP MSA70 disk array sitting on this node to make sure that I can handle the IOP velocity for the number of messages per second that I intend to send into this queue and read out of this queue. Another important point about clusters and scaling is because it is a cluster where everything is aware of everything else, I can connect to node 3 and publish a message that's going to get stored on node 2. And I can connect to node 1 and I can read that message out. But there's a performance penalty for that in scaling, right? Because if I'm having to have the cluster communicate across nodes, pull messages into and push messages out of nodes, in essence, I've, from an engineering perspective, maybe made a lazy approach to how I'm dealing with a cluster, and it's easy, but at the same time, there's a performance penalty, especially over high-velocity queues, where if I just connected directly to the node that manages that queue, I'm going to get some performance benefit. So clusters generally are the way that you scale Rabbit from an architecture perspective, but there's an important caveat to that, which is there's a max cluster size, and it's not a hard and fast rule. I've heard different values from different people. In essence, the consensus, or the number that gets thrown around the most, is around 32 nodes is where you should think about capping out a single cluster size. And that's an Erlang VM level piece. And I know in building out our architecture and how we clustered things out in Rabbit, we were very excited early on and thought, hey, let's stick a Rabbit node on every single one of our web servers. And then use the clustering technology to get that idea of, let me publish locally and then pull out of the cluster somewhere else. And in essence, there becomes a performance penalty the larger the cluster gets. And it's an Erlang VM level penalty that gets imposed. I've heard numbers as high as 48, 50 nodes in a cluster, but the conservative approach is around 30, 32 is where you want to call it quits. So that gives my base overview of Rabbit in AMQP. Are there any questions on the things that I've covered thus far? Because we're going to drill in a little bit more on any of this, or on these different topics. Okay. So scaling issues. Scaling is hard. It's not easy, and by and large, it has a lot to do with architecture and the external forces that apply to that infrastructure, whether it be the consistency of message velocities, right? I may have some sort of workload where I may have spikes in my message velocity that I have to deal with, or the way that I'm distributing the messages. There are constraints around message consumption. Do I have enough consumers coming in, taking the messages out, matching my inbound velocity? All things that you have to be concerned about. And so with that, we have our next poll here. So for the, I think, 12 to 15 of you that have used Rabbit in production, have you run into scaling issues? It's one of those things I hear more often than not when people are talking about Rabbit and they're talking about whatever the coolest new technology beyond Rabbit is, things like ZeroMQ or competing projects like Cupid, that Rabbit has scaling issues. We've got 13 results. That's probably in line, right? So lots of non-applicables there, right? So yes, scaling issues. Cool. So I'll offer the most important aspect of trying to make sure that you're managing to address your scaling issues is this screen right here. This is from the web management plugin. It doesn't ship by default as part of Rabbit. If you install Rabbit on its own, it doesn't have any of the plugins. It doesn't have any of the management tools other than the CLI tools. But this is literally taking and downloading 4 to 5 files from their website that are, probably 100K in total number of bytes, and sticking them into the appropriate directory. And if you have a cluster, you only need to stick the web UI on one node in the cluster, and there's a management agent plugin that you stick on every other node. And it's important because it does one thing on this screen that adds tremendous value, and that is it shows you the operational health of your cluster in very clear-cut ways, looking at just this data on that previous screen. So if we go back here, this is just my local machine. You can see the number of messages that are there, the number of unacknowledged messages. That's fun to watch on a high-velocity cluster to see those numbers bouncing around, but it doesn't offer you a lot of value in trying to troubleshoot or deal with scaling issues. Coming back to here, we have real hard data that tells us what's going on within our Rabbit cluster and where we may run into problems. And so we have file descriptors, and being a room full of operations people and engineers, I'm going to assume you know what file descriptors are. It's an important number, right? It's going to basically be what the operating system allows the process to use as far as open sockets and open files and anything related to interacting with the operating system that the application needs to do, the RabbitMQ application, is directly governed by that number. And so you can see the scale on this is fairly off. I've got 168 here out of 350,000 file descriptors, so I don't see running into an issue here. And then I have socket descriptors, and socket descriptors are within the Erlang process, and it's basically how many sockets is Erlang configured in the VM to allow for your RabbitMQ system to have new connections. And that's a really important number to watch. If we go back and we look at my laptop, I can have 138 connections the way I'm configured right now. That's a pretty big scaling issue. If I've got 1,000 servers and I can only talk to 138 at a time, I've got a pretty big issue. And obviously my MacBook Air is not a production-worthy RabbitMQ box. And then Erlang processes. And Erlang processes, I've heard brought up a couple times through different talks here. Erlang processes are not operating system processes. They're actually lightweight processes within the Erlang VM. And in essence, when you have a connection come in for RabbitMQ, whether it be via AMQP, HTTP, or any other, and I keep almost tripping over this repeatedly, in essence, a new Erlang process is spawned. And that process lives for the lifetime of that connection. And so that's a really important number to watch as well, because if I don't have enough Erlang processes available, I can't accept new connections. I can't use some of the more advanced plugins to move data around. And so just looking at this from a pure communication standpoint, these columns are really important, but not as important as the far right column. So Rabbit likes to live in memory, just like things like your traditional your NoSQL databases or your traditional databases. Living in memory is good. In fact, there are limitations within how much memory Rabbit can use. And so we can see here that if I look at Rabbit 8, currently I'm using 1.2 gigabytes, and I've got an 18.9 gigabyte high watermark. That's an important number, and we're going to go through a little exercise here. But does this ring true to anybody? Any of you with scaling issues? There were 5 of you. Was this one of your scaling issues? Because it's the one I hear the most about. No? Well, this is, I think, the last of the polls here. I'm only expecting 5 results. But have you run into unexplained message throttling? Nobody raised their hand, so I'm just going to bypass this. So in prior versions of RabbitMQ and in the AMQP spec, the specification basically wants your message broker to be a very polite person. I think of it like a very proper English gentleman. And in essence, the way the protocol is written, as a publisher, somebody who's sending messages in, I can send messages, and then the server, at some point when he feels like he's overloaded, like I'm sending too many messages and I'm not consuming enough, he's supposed to send me a message and say, hey, you're kind of sending me messages too quick. Would you mind stopping? Just pause for a little bit, and I'll let you know when I can take new messages in. And AMQP is a fairly lengthy protocol. There are lots of message types. And I would imagine, I know in my case, when I first started writing AMQP apps, I had no idea what channel flow was for. I just wanted to publish messages and take them out. And I didn't write my application to listen for the channel flow message, the one where the broker's saying, hey, you're sending me messages too quickly. Slow down. Stop. Send me a message when I tell you you can send me a message again. And this became evidently a large-scale issue for Rabbit, because in essence, if your clients, your publishers, are not listening for that message saying, hey, please stop sending me these messages, you can crash a Rabbit node, or at least you used to be able to, right? You basically fill up that memory on the right side, the amount of memory I've used. If you're not using disk-backed queues, and I'm sending in all these messages, and so the daemon prior to 2.0 or 2.1, it would send you out these channel flow things, and if you ignored them, you could still publish at the same velocity you were publishing at. You can eat up all of the RAM and crash a node. And so this became such a problem that the Rabbit guys said, hey, that doesn't make sense. Yes, the protocol's there. Yes, people should read the protocol, but people aren't. And we're seeing this high amount of people complaining about Rabbit crashing and running out of memory. How do we do this? How do we deal with this issue? And so what they opted to do is, instead of using that channel flow message frame that I was expected to listen for and react to, they decided that Rabbit should do the work for you. And so Rabbit is now looking when you're publishing to it, and it's saying, you know what, you're publishing messages a little too fast. I'm not going to let you. I'm going to apply TCP back pressure to your connection, and I'm going to stop accepting bytes as quickly as you're sending them to me. And what that manifests as in every client library that I'm aware of, other than the Python Pika library, is really unexplained reduction in message throughput and publishing, right? I have no idea what's going on. I was publishing really quickly, and all of a sudden now my messages are going in really slow or not at all, and my code hasn't changed. There's something wrong with Rabbit. Well, no, Rabbit's protecting you because, in essence, it's doing memory management. And it's saying, hey, you've just sent me 20 gigs of messages, and I've only got 24 gigs of RAM. You better do something with these messages or there's going to be a problem. And so it starts throttling. And so going back to that box, you can see that that high watermark is really important. And in essence, that's a configuration parameter. Rabbit has very few configuration parameters. One of them is memory. And so this is a really ugly configuration format. One of the, if you haven't used Erlang, you're not an Erlang programmer, I should say, is probably the best way to put it. There are some concepts within Rabbit that don't make a lot of sense. Log files, for example. Standard Unix guy, I like syslog, right? You know, it's got a consistent format. I know what to expect when I read a log file. Apache log files, they make sense. Rabbit log files don't make a lot of sense. They use the default Erlang log file system. They're very verbose. They're hard to read. This configuration file format, I mean, does that look like a configuration file format that's easy for non-Erlang people? And Erlang people, you know, don't shoot me, but it's not a very friendly one. And not only that, that 0.4, that's percentage of total memory available on the machine, that's 40%. So all you have to do to increase the amount of memory that Rabbit can use, if you use it on dedicated machines like we do, is go in and change that, you know, from 0.4, do something reasonable, make it 0.9, depending if you have a lot of RAM, you know, 0.8. Find a value that works for you. But in essence, in your Etsy, RabbitMQ, RabbitMQ.conf, that's the content of that file. If you were adding SSL support, it would go in there. If you were using LDAP, it would go in there. Or any of the other plugins I'm going to talk about in a little bit. So there's that aspect of throughput, where you're basically publishing and you're being held back from sending messages because you're publishing too fast and you're not consuming fast enough. Message persistence is another performance penalty in scaling. I talked about that idea of having a disk node and knowing that I can handle the IOPS required to write those messages to disk, pull them from disk and remove them from disk for every publish and consume. Rabbit's own FAQ basically states that there is a 50 to 70% performance penalty in message throughput by making messages persistent. That's not insignificant. And then consuming. And consuming has a scaling issue of its own. There are multiple ways that we can consume messages from Rabbit. We can do it that polite way. Really, if you care about your data, you care about those messages the way that you should, which is Rabbit sends you a message, you receive it, you do what you're supposed to do with it, and then you say, hey, I got that message and I processed it. That's a basic ACK. Or, hey, I got that message and I really couldn't do anything with it, you know, take it back. And that's a basic NACK or a basic reject. Or you could say, hey, Rabbit, I don't really care if I lose a message or two in there. So I'm not going to ACK. Just send me the stuff as fast as you can send it to me. And so in that case, what Rabbit does is he basically fills up the TCP buffers, just sending you messages. And to give you an idea from a traffic flow perspective, the basic deliver frame is what's responsible for sending you a message. And this is actually fairly abbreviated. What receiving a message in Rabbit looks like is you take frames, and they're 131 bytes in size by default, and you have a basic deliver frame, which is a method frame, and it says, hey, client, I'm going to send you a message, and be ready for it. And then the next frame that comes down is the header frame for the message, and that has your properties. You know, what was your content type, your timestamp, your application ID. And then you're going to have 1 to n number of frames that are the body of the message, the actual message that you're sending in 131 byte chunks. And so you're going to receive those on that first arrow. And then coming in, if you're going to have that type of communication where you're doing a ACK or not, you're going to send as a client, I've received the message, I've processed it, I've done what I'm supposed to do. RabbitMQ, we're good to go. Well, that's not good enough. RabbitMQ has to then come back to you and say, okay, I got your acknowledgement, we're all good. That's pretty chatter. I mean, that's a pretty verbose protocol as far as making sure that that confirmation takes place and everything is working the way it's supposed to do. Yes? 131K max byte frame size. If it's smaller than 131, I mean, it is smaller. The reason why I was bringing that up, if there's a, let's say you're sending an image and an image is 1 meg, it's going to bump into, in essence, what is 8 bytes, 12 bytes, I believe, plus whatever it can chunk it into in 131K byte sizes, sitting on top of TCP. No. The basic deliver on its own is going to be somewhere in the realm of maybe 120 bytes. The basic ACK is going to be somewhere in the realm of 60 bytes. It's small. Sorry. So you have this, and this works really well from a message flow perspective. You know, everybody knows what's going on. We're all in the loop. We're all in agreement, you know, to what's going on. Or you can take this approach, which is I'm just going to shove messages at you as quickly as you can take them, and I don't care if they spill all out over your clothes, right? I don't care if you're going to blow up on the other end. The problem with this approach is when he eventually blows up, all the messages that he received, whether he processed them or not, are gone. Rabbit didn't sit there and wait to figure out if he consumed them or not and whether he kept them down. And so that's really fast. I can take messages and I can scale incredibly quickly. And so at myYearbook, an example of our usage of this is heartbeat data from client browsers down to our backend message bus. We don't care if we lose heartbeat data, right? Because we're sending it fairly quickly, and it's very repetitive. And if I miss one message out of every 5 seconds, you know, 1 out of 15 seconds because the consumer died, and really what we're talking about is this idea of a contract where we're just making sure that the consumer, the guy receiving the messages, can still process. So if I have an operational event where I lose that consumer, he goes away and he doesn't process those messages, it's not the worst thing in the world. I'm not a bank, and I'm not running financial transactions, and I don't need to make sure that heartbeat data doesn't go away. Where I am doing financial transactions, absolutely, I would not use this approach. But this approach works pretty good for high-velocity message throughput. The other end of the equation is basic QoS. So you can set the quality of service for a consumer, and that can be on a specific channel within Rabbit. Maybe I should take a step back and explain that. Within a connection to Rabbit, and within the AMQP spec, you have your socket level connection. And then within that socket level connection, you basically have what is nothing more than a prefixed namespace or a numerical ID that you're communicating over called a channel. And you can have that channel, you can have, gosh, I don't even remember what the max number of channels are, but it's probably max int value. And in essence, there's nothing to channels other than the fact that when I open a channel, I'm in the frame at the low level, I'm just saying, hey, this is for channel 1, and Rabbit's coming back from the other end saying, hey, this is for channel 1 as well. So it's a way for my client to basically keep track of multiple different types of workflows that are going on within that same client connection in essence. And so with basic QoS, I could say, hey, for my entire client, for this entire connection, or for just a channel within this connection, only send me one message at a time and wait for me to send that ACK back before you send me another, or send me 10. And then, so pre-allocate me 10 messages, send them over to me, I'll process them, I'll ACK them, and I'll send them back. The higher that number is, the higher number of bytes that I set in basic QoS, the higher number of messages that I set in basic QoS, the faster my throughput is. Because Rabbits are making these decisions ahead of time and sending me 10 at a time, or how many ever I ask for at a time, as opposed to a very synchronous one-for-one type of approach. And so, you know, it's an important lever to pull in trying to manage your throughput. And you have to, again, figure out what's what's appropriate. Now, the nice thing about taking the approach of having a high QoS is any unacknowledged message stays within RabbitMQ until I acknowledge it. So if my consumer dies, I can basically send a frame called basic recover, and now all those messages that were stuck in an unacknowledged state can be sent down to somebody else. And so I didn't lose anything, but I gained some efficiencies by having Rabbit pre-allocate a certain number of messages for me. Wow, that's quick. Okay, too many short-lived connections. I'm going to try and breeze through this really quickly because I've got 5 minutes here. In our environment, we are a PHP environment by and large for 95% of our application. And the model there is Apache and mod PHP. And what Apache and mod PHP looks like, for those of you that don't live in PHP land, is for every Apache back-end process, there is an interpreter. And even when using connection persistence on that single back-end, so let's say I've got 250 Apache backends that are accepting connections to furnish requests to my HTTP clients, and I have consistent or persistent sockets open, one per backend. If I've got 100 servers, 125 backends, and I'm doing one request a second, and I'm not maintaining connection persistence, I'm making 12,500 requests per second or connections per second to my Rabbit server. That's a big number, and connection persistence within AMQP and PHP is very, very difficult to do correctly. I haven't seen it done correctly, and it's not something that is really a viable option today. And let me just go over really quickly what an AMQP connection sequence looks like. So you can see we send a protocol header frame, that's 8 bytes. We send a connection start and a connection start OK, that's roughly 250 bytes, somewhere in there. This is a synchronous conversation that's happening every time I connect to the server. Connection start OK, connection tune OK, connection open OK, and then channel open and channel open OK. The important aspect of that, start, I'm saying, hey, I want to start, I'm going to say, I want to talk to you over AMQP 0.91. The server says, OK, let's talk that. Here's what I can do. Connection start OK says, OK, I can do that thing too. The username and password I want to use are X and Y. Great, let's tune our connection. What's the maximum frame size you want to use? 131K? Great, that sounds good. I like that idea. Oh, by the way, I want to talk to you on vhost XYZ, and here's some other data that's important. And okay, yeah, hey, we're good. Okay, let's open our channel now. We can start doing our things. Now, altogether, that 685 bytes per connection. At 12,500 connections per second, that is 8.6 megabytes per second for connection startup alone. How do you scale that? Persistent connections, but you can't do persistent connections because, in essence, it's a stateful protocol. And so how do I know that my previous use of that connection is left in the right state for my next connection coming in? There are assumptions about connection persistence in protocols like Memcache that are pretty easy to deal with. In AMQP, not so much. And so what we did at myYearbook is we created a system called Vorpal Bunny. In essence, it's a lightweight wrapper. It is written in PHP and uses the JSON-RPC-Channel plugin and uses HTTP to talk to RabbitMQ and send these messages as a fire and forget. Here's a message, here's a message, here's a message. It, in essence, is AMQP over HTTP and manages that state for you in a way that makes sense. The problem is it can't be transparently load balanced because it does maintain state. It needs to know what server it has to connect to. So I'm going to jump ahead here. Velocity too high for one node. This was a gotcha. This was a disaster point I was going to talk about. We launched a really cool app. It's that app that basically maintains the browser to message bus connectivity. And it was going really well. We launched and the whole thing was running really well. And about 10:30 at night, I'm sitting in my office and I'm watching these numbers and I'm looking at the dashboard and I see that number going and it's a really high message velocity rate. Very cool. And then I look down and I see that bar with memory utilization and it turned from green to red. Well, I don't get it because my messages are publishing really fast and I'm consuming really fast and everything is cool. What's going on? My memory utilization was disproportionate to the queue depth. And I got 1 minute left, and so I'm going to run through this really quick. In essence, I was publishing so quickly into one node, it couldn't effectively manage its memory. And I was pushing all my messages and pulling all my messages out of one node in the cluster and letting it make all the decisions. I overwhelmed the one node in the cluster. It was an architecture problem, not a Rabbit problem. By moving and shifting things around, I was able to publish into different nodes and consume from different nodes and maintain the same message velocity while not overwhelming a single node. And so that there's an example of architecture over technology. Cluster node failures really quick. I'm going to run out my time here and see where we get cut off. If you lose a node, it takes up to 60 seconds to detect it. Every 60 seconds, Erlang runs through and says, hey, is everybody there? And messages are dropped on the floor during that period of time. Thankfully, in 2.6.0, active queues were added. So now I'm sending messages, it's getting stored on multiple nodes, retrieved from multiple nodes. That does have a performance penalty, as you would imagine. You can also do active passive failover using DRBD and pacemaker. And so should I lose a new node comes in and takes its place. But recovery is hard in those aspects. And so basically what that looks like is going in and stopping and starting cluster nodes and taking your system down in production in order to recover those clusters. So there are alternatives. Federation, where I'm taking data and moving them from one cluster to another at the exchange level. Shovels, where I'm taking data at the queue level and moving it into an exchange on another cluster. But the most important part of scaling is making sure that you're doing trending and monitoring, making sure that you're watching your message rates, your memory utilization. Use the management API plugin, doing RESTful calls and taking that data and shove it into Nagios, into Cacti, into Munyon, whatever it is that you use for your trending and analytics, Circonus. Take that data, watch it, look for trends, and address it at the architecture level. And that's it. Okay, so I have time for 2 questions after running through that very quickly. Are there any questions? Yes. Well, it's a design by committee protocol. And from 0.9 to 1, you added Microsoft, you added Bank of America, you added Barclays, you added a whole bunch of different organizations into the process. And the financial industry is very vested at this point in AMQP as a protocol. That idea of being vendor neutral and platform agnostic or platform neutrality added things into 1.0 that really the focus of 1 is somewhat different. There will be ongoing compatibility for 0.91. Rabbit will include 1.0 compatibility, and there is some mind shift, and I think it really comes down to the client library implementers to make sure that we are creating APIs that are consistent and may be used consistently across the different AMQP implementations. 0.8 to 0.9 was a very easy jump. It was basically like feature set stuff. 1.0, I'm still in the process of digesting and going through documentation and figuring out what that means for the Python library that I maintain. I don't have a full, clear picture of how that gets translated and what that looks like. The important thing to know is 0.91 is not going away. 1.0 is not officially finalized until the Wednesday after next at the AMQP event in New York City. So there's still a pretty big window there.
All right, thank you very much.
Thank you.